Today we're going to continue our lessons on probability, and we're going to focus on finding compound probabilities or probabilities of unions and intersections. And we're also going to use complements to find the probability of an event. Okay, first thing you need to know is that a union or intersection of two events is called a compound event. What this means is, if you've seen a Venn diagram before, sometimes you have things that are in common between two situations or two groups, and those go in the middle of your Venn diagram, and things that are unique go on the sides. Well, when we're talking about a union, that means it could be either A or B, or A and B. And when we're talking about an intersection, we're only talking about where they overlap, so just the A's and the B's. This last diagram shows things that are mutually exclusive. That means it doesn't matter what happens with A, it's not related to what happens with B. Okay? So, to find the probability of a compound event, we are going to look to decide if they are mutually exclusive or not. If they are mutually exclusive, we can just add their probabilities together. And if they are not, then we need to subtract the cases where both of them happen to so that we don't count situations twice. So, a card is randomly selected from a standard deck of 52 cards. So look back to your deck of cards reference sheet. What is the probability that it is an ace or a face card? Okay, and remember from the last lesson, the word or means we are going to add our probabilities together. So, an ace on our list, there are 4 aces out of 52 cards. Okay, and then there are 12 face cards out of the 52 cards. And then you need to ask yourself, are there any aces that are also face cards? Which there aren't. That means that's mutually exclusive. So if I combine those together, I get 16 out of 52, which I can reduce to a fraction or a decimal. So 4 out of 13, or a probability of 0.308. Okay, so those are mutually exclusive because they don't have any overlap. The next problem, we have a card is randomly selected from a standard deck of 52 cards. What is the probability that the card is a heart or a face card? So if you look at your list of cards, there are 13 hearts out of 52 cards, and there are 12 face cards out of 52 cards. And then if you look at the list of hearts, there are also 3 cards listed in your hearts that are face cards. This is because there's overlap. We have hearts that are jacks, we have hearts that are queens, and we have hearts that are kings. So those are the 3 that are counted in both. So these are our hearts, these are our face cards. So we need to subtract that out, otherwise we're counting it twice. Okay, so we're going to combine those together. 13 plus 12 is 25. 25 minus 3 is 22. And I can reduce that to 11 out of 26, or find the decimal, which is 0.423. Okay, for this next problem, we actually have a Venn diagram here showing us our situation. Last year, a company paid overtime wages or hired temporary help during 9 months. Overtime wages were paid during 7 months, and temporary help was hired during 4 months. At the end of the year, an auditor examines the accounting records and randomly selects 1 month to check the company's payroll. What is the probability that the auditor will select a month in which the company paid overtime wages and hired temporary help? So let's look at the situation here. If we count, we have 1, 2, 3, 4, 5, 6, 7 months where they paid overtime wages, and 1, 2, 3, 4 months where they offered temporary help or hired temporary help. And then we have 2 months in the middle where they actually did both. Okay, so if we keep that in mind, that means there's a total of 9 months here where they had to pay either overtime or hire extra help. Now, the probability that the auditor will select a month in which the company paid overtime wages and hire temporary help is this overlap here, so that happened twice. And keep in mind, even though there's only 9 months here, there are still 12 months in a year. So 2 divided by 12 is 1/6, or 0.167. Okay, there are a couple guided practice problems here. Go ahead and hit pause and try those, and when you are ready, hit play again, and the answers will be up there so you can check them. Okay, first you actually get the same answer. You get 4/13, or 0.308. And then the third one, you actually get 10% for an answer. If you have questions, make sure you ask. Okay, sometimes it is easier to actually find what we call the complement or use complements. So the event A prime, okay, so the event A prime, this is A prime here, called the complement of event A, consists of all outcomes that are not in A. So what we do to do that is 1 minus the probability of getting A would find the probability of not getting A, because all probabilities add up to 1. So sometimes it's easier to figure out when the case doesn't happen and subtract it from 1 to actually find that probability instead of counting everything possible. So when 2 6-sided dice are tossed, there's 36 possible outcomes as shown. Find the probability of the given event. First, find the probability that the sum is not 8. Well, there's 36 cases here. We could go through and count all of those, or we can find the ones where it actually is 8. So we're going to find the complement here. So instead of finding not 8, let's find where it is 8. So I have 8 here, 8 here, 8 here, here, and here. So there's 1, 2, 3, 4, 5 cases where the sum is 8. So 5 out of 36. If I subtract that from 1, we actually find when it would not be 8. Okay, so we're kind of doing the opposite there and then subtracting it from 1. So if you remember how to subtract fractions, 1 minus 5/36 is really 36 minus 5, which is 31 out of 36. Or, as a decimal, 0.861. Okay, for the second one, the sum is greater or equal to. So they want to know when this is happening. So I really want to check for this to see when it's a little bit easier. So when is our sum less than 4? Okay, notice I said less than, not less than or equal to. So less than 4, there are 3 of those. So 3 out of 36 are less than 4, which means they're not greater than or equal to. And we're going to subtract that from 1, so I end up getting 33 out of 36, which reduces. If I divide them both by 3, I get 11 out of 12, or as a decimal, 0.917. Okay, so those complements definitely made that a lot easier to handle instead of trying to calculate that by counting all of those. Okay, one more. 4 houses in a neighborhood have the same model of garage door opener. Each opener has 4,096 possible transmitter codes. What is the probability that at least 2 of the 4 houses have the same code? So, here's what I will tell you. There are 4 houses. Each of those has 4,096 possible options. Okay, so this is our total number of possible outcomes. Okay, and instead of trying to figure out how at least 2 of them have the same code, we're going to figure out what are the chances that none of them have the same code. So to do that, if the first house picks from the total number of options, the second house can't use that same option, so we're going to take 1 away. The third house can't use the other 2. That's a 4 there, not a 6. And then the last one can't repeat either. Okay, so we just found the probability that none, that looks like a W, I apologize, that none are the same. Okay, so if I multiply all that out and divide it, I'm going to type all this in my calculator on the top, divide by all of this in the bottom, I get about 0.99854. Okay, so this is the probability that none of their garage door codes are the same. So to figure out that probability that at least 2 of them have the same code, I'm going to subtract that from 1 and use the complement, which gives me 0.00146. So that's a very slim chance there that they would end up with the same garage code. Okay. There's a guided practice problem here. Go ahead and try that problem, and then when you are ready, hit play to check your answer. And your answer should be 0.795. Any questions? Make sure you ask. Have a great day.